In this tutorial I'm going to look at the electrolysis of molten ionic substances, such as in this diagram, lead bromide. Such a substance will not conduct electricity when it's solid, but it will conduct electricity if it's melted. You should understand why an ionic solid won't be electrolyzed when it's solid, but can be when it's molten, to do with the ability of the ions to move in the molten state but not in the solid state. You should also be able to construct half equations for electrode reactions for the electrolysis of molten ionic substances. Let's recall what we learned about ionic substances earlier in the course. Ionic substances are formed of ions. Take this sodium bromide made out of sodium ions, Na+, and bromide ions, Br-. Because these have got opposite charges, these attract each other and form into a crystal lattice, such as shown here, where there's very strong attractions between the oppositely charged ions. Now, because the ions are so strongly held to each other, they can't move when they're solid and they don't conduct electricity. These ions can only be separated in one of two ways. One way is to dissolve them, in other words to make an aqueous solution of the sodium bromide, and that of course with the ions being able to move would conduct electricity. The second way we can get the ions to move is to melt it by heating up to a high enough temperature that the attractions between the ions are broken. This molten sodium bromide would also conduct electricity and electrolysis would happen. Let's then look at the electrolysis of these molten or fused salts, starting with our example sodium bromide. Sodium bromide is made up of sodium ions, Na+, and bromide ions, Br-. So the sodium ions move towards the negative electrode, the cathode. Each sodium ion picks up an electron from the current to form sodium atoms. So sodium metal is made there. Whereas the bromide ions move towards the anode here. Each bromide ion loses an electron to form bromine molecules. Looking at the other examples, silver iodide would be made out of silver ions and iodide ions. At the cathode, the silver ions, Ag+, would each gain an electron to form silver. This would be at the cathode. Whereas at the anode, the iodide ions, two of each iodide ion, they would give away two electrons to form iodine molecules. Sodium chloride, well, the sodium ions at the cathode, the sodium ions would each gain an electron to form sodium metal, whereas at the anode, the chloride ions, two of them, would give away two electrons to make chlorine. Finally, magnesium oxide at the cathode, the magnesium ions, Mg2+, would gain two electrons to form magnesium atoms, whereas at the anode, the oxide ions, two of them, would lose a total of 4 electrons to make oxygen gas. This question is about electrolysis. Look at the diagram. It shows the apparatus needed for the electrolysis of molten or liquid lead bromide, and we've got carbon electrodes in a ceramic crucible heated up to make molten or liquid lead bromide. Look at the symbol equation. It shows how lead bromide is broken down during electrolysis. So the lead bromide under electrolysis will make lead at the cathode and bromine at the anode. Electrolysis involves the movement of ions. Molten or liquid lead bromide can be electrolyzed, but solid lead bromide can't. Explain why. Well, here, solid lead bromide has ions, but these are in fixed positions in a crystal lattice and cannot move, so cannot carry charge. And molten lead bromide contains lead ions and bromide ions. Bromide ions lose electrons at the anode to make bromine molecules. Construct an equation for this. Well, we're starting off with bromide ions. We're ending up with bromine molecules, so we need 2 of those, and also we need to lose 2 electrons. And a final question, during an experiment 9.65 amps is passed through molten lead bromide for 100 seconds, a mass of 1.035 grams of lead was made at the cathode. In a second experiment 19.3 amps, that's double, is passed through molten lead bromide for 50 seconds, well that's half. The same mass of lead was made at the cathode. Explain why using ideas about current and time. Well, here we might state that if we double the current, we double the mass. If we halve the time, we halve the mass. So the effect on the mass equals 2 times a half equals 1, so the mass stays the same. Here's the answer. In the first part, the idea that the ions can't move in the solid, or they're in fixed positions, or can only vibrate, or they can only move in the liquid. In the second part, either we can show the electrons being taken away on the left hand side, or we can see them being produced on the right hand side. And finally, the idea that as the current increases, the current or the current doubles, but the time decreases or the time halves, or the same idea in terms of coulombs, although I do stress that the idea of coulombs isn't strictly on the syllabus.